Okay guys, we're out here in the shop and got the mill running again. I'd taken it all down and made some big improvements and done a few things to it. So since the last time I posted a video, figured I'd run a program and put something up since I haven't done anything in a while. There's a couple of fans running in the background, air conditioner, so might be a little background noise. Hopefully the mill won't be too loud for you guys. Done a lot of work to it, a lot of upgrades, a lot of improvements. Hopefully things will go along all right on this one. I'll go ahead and get it started. Running a piece of the conversion kit just to give a little sample video of the upgrades on the machine. I'll try to pan around while it's running a little bit and let you see if I can. Hopefully the coolant won't become an issue. I got the camera tucked off in a corner over here. Hopefully there's not much coolant going in that direction. I'm not sure. We'll have to wait and see. Okay, well, we'll go ahead and get this thing going here. First thing we're going to do is we're going to run a fly cutter across the top of this block. Establish a deck to do all the other machining on. This will be 750 RPM at 8 inches a minute for a pretty good finish on the top. Sounds pretty good there. Not much cooling on this end too, so that's good. You can see you got a 1.5 marathon inverter duty motor on here now with a power drawbar, belt drive, no more gears, a lot quieter, a lot smoother, much better. Upgraded the water pump, the coolant pump. It's a 1/4 horsepower, 15 psi. A lot better. Got it turned down a little bit right now because it doesn't take much pressure for the fly cutter. This will be the last pass for the fly cutter. This is the finished pass. Next process is going to be a number 9 drill, which is a tap drill for M6 thread. So I'll change the tool out and get that process going. It's 1500 RPM on the drill. About 4 inches per minute feed. It's pecking at about 0.60 depth. I hope this control fan not too loud over here. There's a VFD fan and a control fan over here. Next process is going to be a S drill. It's just a clearance drill. Remove some material. We're going to do a bore once we get done removing this extra material out of the center. Kind of help the end mill out a little bit. $1,500 RPM also on this bit. It's 4 inches a minute and it's pecking about 0.90. It's a boring operation here. It's 3,000 RPM at 15 inches a minute. Say think it's a 1.5 degree ramp, and it's a 5/16 3 flute Alu Power YG1 end mill. Like I say, it's 3,000 RPM. This end mill is going to go down in there all the way down pretty tight. So I've got a longer one ordered for longer jobs. I've got a longer one, but it's way too long. So I got one that's about middle way. It'll be a lot better. This one, I'm pushing this one all the way to the limit on this depth, on this bore here. It's just a clearance bore, so it's not real crucial. Quite a bit more flow there on the new pump. Keep those ships flushed out of that pocket. Doesn't do much for being able to see what's going on, but it does get the chips out of the way. Come back in now for another pass going down in. Step over on that. It's 2 step overs, and it's 90 thousandths. And then there'll be a couple of finish passes after that. A little bit of rattling you hear is the splines on the quill tube driving the spindle. Okay, it's got that pocket done. I'll see if I can get you close enough to see what it looks like when it's finished on the inside. If I can remember which way to zoom. Pretty good finish there with that end mill. I can't get it completely dry in there so you can see. That's a little better. You can see the top finish up there smeared a little bit. Okay, the next thing we got to do is change the tool out to a 1/2 inch YG1 3 flute. That's an 1.25 inch depth of cut or length of cut. It's actually has a little more length of cut than that, but that's the specification on it. So we're going to be running about 1.259 on the depth of cut, which is about all that I could get out of it. So like I say, this is just the tooling that I have right now. I've got more tooling ordered to handle these deeper cuts. You know, it's pushing it a little bit farther than what the end mill should go, but if you taper off your loads, it'll handle it fine, as you'll see. Okay, this is going to be a 4,000 RPM, and I ran a piece at 25 inches a minute earlier, and it was just a little bit more than I felt comfortable with, so I bumped it back just a little bit by manual override on the feed. Slowed the feed down just a little. I think it's going to be somewhere about 20 inches per minute. And the optimal load on this adaptive is going to be 70 thousandths. So that's a pretty good cut. That's a pretty good cut for 1¼ inch depth of cut, 70 thousandths width of cut at about 20 inches per minute at 4,000 RPM. About all that end mill is going to want to handle. It's 20 inches a minute, 4,000 RPM. That's just about all it can stand right there, or at least all my machine can stand anyway. Pick up a little bit of vibration there on that 70 thousandths load there, so it probably could back off on that to 60 and it would be perfect. This is going to be a trace around the outside to clean up that adaptive, running 2,500 RPM at 7 inches per minute. Okay, it makes pretty much short work of that. Makes a big mess, but it makes short work of it. Okay guys, the motor, this particular motor and belt drive combination is a Marathon 1.5 inverter duty, continuous duty motor. It's a Micromax. Okay, this is a 4-pole motor. It runs at 1800 RPM. This motor has a lot of power all the time because it's 1000 to 1, so that gives it a continuous torque at all RPM, pretty much all RPMs. It can handle the fly cutter all the way down to 750 RPM on a 3-inch width of cut, which is a full width of cut for this spindle. The belt drive Sam and I have been working on for a while. He made the pulleys to come up with all the design together on the lift plate for the power draw bar and the risers for the Marathon, and I believe he's got some design work on the metric style motors as well, which is what he is running at the moment. He should be releasing a video on, I think he's already done a video on the modified belt drive with his metric motor. This is a Marathon motor, so has a lot more power. It's a lot smoother. There's no fan on it, so there's no issues with the fan being out of balance and all. So that's pretty much the top end of the machine. I had to machine a larger spacer to get room for the motor between the column and the motor and allow a little bit of adjustment for tightening the belt and whatnot. Does a fantastic job. It handles that. Handles anything I need it to do. It's going to be able to do for me. Makes some pretty good chips with it. Makes really nice parts. So I get a shot of some parts here in just a moment. I get this thing out of the vise and get it where you can look at it. Okay guys, there it is right there. This is the, got a little bit of wiping going on right here. You can see it. It's just such a deep cut there, and I'm still playing around with the finish feeds and stuff. Pretty good. Still a lot of room for improvement, but it's a lot better than it was. No issues with pull out on the power draw bar, so that seems to be working really good. I'm real pleased with the finishes. These end mills really do a good job, fantastic job. Buddy of ours, Chris, over at Small Shop Concepts, turned us on to these end mills, and big shout out to him. Thanks a lot for sharing the information on those end mills. They really do a fine job. Getting down in that bore there, it's like a mirror in there, and that's just a cleanup bore. I mean, just a clearance bore, so no special attention on that. Alright guys, well, I guess that's going to do us on this video. I got a couple more pieces to run here on this run. So So I appreciate you guys watching, hanging in there, waiting around for new videos and stuff. It's been a little bit of a task getting all this stuff worked out. Got the cabinet all straightened out now. It's all in, got everything in there. VFD, smooth stepper. This is a line reactor over here, a filter for the outgoing to the motor. Then there's an EMI right below it, which is incoming from the circuit going to the VFD. It isolates all of that so it doesn't go back and get all in the rest of the system. Power supply, transformer for a home circuit, 2 contacts, spindle contact, home contact for the whole machine, and then the power supply, got it off the wall and I've moved it over there into the closure for now. Hopefully it'll handle it alright. So everything's in there. I got to finish buttoning it up, getting a cover on it and all. Everything seems like it's going to work okay like that, so we'll let it go the way it is for now, and I'll get it buttoned up when it's rock solid. So I may end up having to change the end of the cabinet. I'm not sure. If it can't handle the weight, then I might have to change it. It's all made out of plexiglass, as you can see, so quite a bit of weight hanging there on that glass. So okay guys, well, thanks for watching. Thumbs up if you like the video, subscribe if you like.